Greetings, class. We are still working on Chapter 8, Section 3. Takes a little longer to get through these problems because we're trying to identify the null and alternative hypothesis. I'd like to look at question number 18, mainly because I can open it in StatCrunch and we can do the work. It says the scoring averages in points per game of 10 professional basketball players for their rookie and sophomore seasons are shown in the table below. At alpha equals 0.10, is there enough evidence to support the claim that the scoring averages have changed? So we're going to first of all try to determine what is the null and alternative hypothesis. So it says, is there enough evidence to support the claim that the scoring averages have changed? Now remember that the mean of the differences is equal to the mean of the differences in sample 1 minus the mean of the differences in sample 2. Now, if the scoring averages have changed, that just means that they're not the same, that D1 is not equal to D2. So that would mean that their difference would not be equal to 0. In this case, that inequality would have to go with this particular symbol. Sorry, I lost my not equal to. There we go. And so that one would be not equal to 0. And the mu sub d, as a result, if the alternative is mu sub d not equal to 0, then the null hypothesis has to be the equality statement that goes with that, which in this case would be equal to 0. So I've got my null hypothesis that the average of the differences is 0, and my alternative hypothesis that the difference in the means is not equal to 0. This one, again, at the bottom, H sub A, is our claim, because that means that the scoring averages have changed. In this case, D1 is not equal to D2. So their differences would, if they're not equal, their difference wouldn't be equal either. He didn't say it improved or that it got worse. He just simply said it's not the same. And so our test here is going to be a two-tailed. So since H sub A is not equal, since H sub A uses the not equal symbol, then we do a two-tailed T calculator to find the T sub 0 critical values. So I'm going to pull up StatCrunch and come back here in just a second. All right, so we are back in StatCrunch. I've got a blank data table, and I'm going to run the T calculator to find the critical value. So I have to go to Stat, Calculators, and a T calculator. Now, because this is two-tailed, that means we're going to have to use the between option. Now, if I go back and look at number 12 in my book, it says, number 18, alpha is 0.1, and there are 10 players. Alpha is 0.1, and there are 10 players. So if there are 10 players, my degrees of freedom is 1 less than that, or 9. Now, normally, when we do these, if it's a right or a left tail, we use alpha. But with a two-tail, we have to use 1 minus alpha. So alpha is 0.10, then 1 minus alpha would be 0.90. And when we compute, we see that the T criticals are negative 1.833 and positive 1.833 to 2 decimal places. So we're going to add that information here. So t sub 0 is equal to 1.833. It capitalized it whether I wanted it to or not. And negative t sub 0 is equal to negative 1.833. Now this is the only picture we look at where we have some issues with where the rejection region is. Because I have to use the between for a two-tailed, and the between part is the 0.90 that is not the rejection region, I have to look at the tails on each side. I have to look at the two tails, not the center, but the two tails. So the rejection regions, in this case there are two of them, if my standardized value for t was over here on the left, it would be less than this negative value. So if t is less than negative 1.833, or if that t is greater than a positive 1.833, that would be over here on the right. So, for example, if you had a t value of 2, that would be in the rejection region because it'd be greater than 1.833. Or if you had one that was a negative 3 over here, that would be less than a negative 1.833. So these are your rejection regions. It's this white area on the right for the greater than 1.833, and it's also this white area in the left tail for the t less than negative 1.833. Now, we've got our rejection region, but now we need to determine our standardized test statistic. And for this one, we will have to run the t-stat test, but it will be for paired data. So I'm going to go back to the problem and open it in StatCrunch, and you'll notice there's a rookie season, and it looks like StatCrunch was a little crazy here. I'm just going to, I'm going to hold that and click here, and then I'm going to do a Control-C. I'm going to put it over here and do a Control-V, and then I'm just going to edit, and I'm going to go to columns, and I'm going to delete that var 3 so that I don't see duplicates. There we go. So now we see the rookie season. I'll scoot that over so you can see the word. Rookie season, these were their scoring averages for a basketball player. And their sophomore season, this was their scoring average. So I'm going to make this where we can still see our paper because we need to see our H sub A to determine our symbol here. So we're going to go to Stat. T-stat, but remember this is paired because they are dependent samples. In column 1, we have the rookie season. Sample 2 is their sophomore season. Please save the differences. I'm going to remember this time to go through how to find the standard deviation of the differences. We are doing a hypothesis test. Our value for mu sub D is 0, so we can leave that 0. And our symbol for H sub A is not equal. And that's the default symbol, so we're okay there. I am going to request that my output be stored in the data table. So I'm going to click Compute, and I will close that option window. And it says that the t-stat, that the t standardized test statistic is equal to negative 1.327 to 3 decimal places. Now, since it's a negative number, I want to compare it to the negative side. So you have to ask yourself, is this value of t less than a negative 1.833? Or rewriting that, you would say, is negative 1.327 less than negative 1.833? And your answer is no, it's not. So it's not in the rejection region. So we fail to reject H sub O. Now, I do want to tell you there's another way to look at this, and that is this p-value. I'm going to do a Control-C, and let's just put it down here. So this is another option to determine whether we reject H sub O or fail to reject H sub O. So your p-value is equal to 0.217. I'm just going to bring that down to 3 decimal places, 0.217 to 3 decimal places. And remember that we can ask if the p-value is less than alpha. And if the answer is yes, then we reject H sub O. Well, so we ask ourselves, is the p-value less than alpha? Well, our p-value was 0.217, and our alpha, if you remember back from the problem, our alpha was 0.10. So if you ask yourself, is 0.217 less than 0.10, the answer is no. So we fail to reject H sub O. Now that's exactly the same result we got by asking about the rejection regions. When we were looking at these rejection regions, we had to ask ourselves if t was less than 1.83. But if we did the p-value, I'll just change the color on that. We could do the p-value. We just ask, is p-value less than alpha? And when we looked at that, the answer was no. So we failed to reject H sub O. But we still failed to reject H sub O even when we were looking at the rejection regions. So you can do it one of two ways. It's just what MyStatLab asks you to do. If they ask you to write the rejection regions, then you're going to have to do that. But if they don't say how you're supposed to work it, and if they don't ask you for a p-value, you can still use the p-value to come up with your answer there. So let's interpret our answer. So our interpretation, if we fail to reject H sub O and our claim is H sub A, what that means is there is not enough evidence at the 10%, because alpha was 0.10, so that's 10% level of significance, to support the claim. So there's no evidence to support the claim that their scoring averages in points per game have changed. Now, I reminded you I was going to go back and look at StatCrunch because we had these differences. And I'll tell you, in one of the homework questions, it wants you to find the standard deviation of these differences. And sometimes it wants the mean of those differences. So in order to do that, if they ask you for either the mean, D bar, the mean of the differences, or S sub D, then you can find those simply by doing summary statistics on the differences. I'm just going to go to Stat, Summary Stats for a column, and that column is the differences column, and I'm just going to let it do all of them. So if I compute all of them, do you see standard deviation right there? So that would be the standard deviation of the differences, because that's the column. There's the mean of the differences, and there's the standard deviation. And so those were two questions that I noticed that the book that MyStatLab asked for And I didn't want you to feel like you had to do all the calculations. If they give you columns of data,